In this video, I'm going to solve this problem. So I'm asked to show that this equation has a solution on the interval 0, 1. And this is a good candidate for using the intermediate value theorem because I could pull that over to this side, and now I'd want to show that a particular function is equal to 0 on the interval 0, 1, which I can likely do using the IVT. So the first thing I'm going to do is I'm going to rewrite the equation. So this is the same as showing that this equation has a solution on 0, 1. An alternative option would be maybe to get the constant 1 on one side, and then you could apply the IVT by getting a value less than 1 and a value greater than 1, but I'll use 0. All right, so first of all, I note that if this is my function, then it will be continuous. It's actually continuous everywhere, right? So let's let f of x equal 1 minus x minus the cube root of x. Okay, so it's definitely going to be continuous on the closed interval 0, 1. So I like to do a little rough work before writing out a really nice solution. And I'm given the interval 0, 1. So the first thing I do is I try those endpoints. F of 0 is equal to, so it's 1 minus 0, so that's 1. And what I'm looking for to apply the IVT, I'm looking to get one function value that is larger than 0 and one function value that is less than 0. Now, 1 is certainly larger than 0, okay? And let's check the other endpoint. So f of 1 is equal to, well, f of 1 is 1 minus 1 minus 1, which is minus 1, which is certainly less than 0. So this is great because I've found an x value that gives me a function value that is greater than 0. So I know that the function is sitting above the x-axis at that point. And I have found a function value that is less than 0. So I know that it's sitting below the x-axis at that point. And what the IVT tells me is because the function is continuous, it then has to cross that x-axis, giving me that value 0, okay? So now I should write up a proper solution. So this is my rough work over here, and let's write up a nice solution. So this is the IVT. So the first thing you need is you need 1, that your function is continuous on the closed interval 0, 1. 2, you need that one of those function values at the endpoint is less than 0 and one is bigger than 0. So you have f of 0 is equal to 1, which is bigger than 0. And you have f of 1 is equal to minus 1, which is less than 0. Okay, so you can say by the IVT, there is some value c inside the open interval 0, 1, such that f of c equals 0, right? So that tells us that there is some solution to this equation on that interval.